The next lesson is dedicated to parabolic regression example, which is an example, a very interesting example, in which the variance increases with the regression variable, that it is an heterostochastic model. We will also explain how to obtain percentiles of the percentile curves. And finally, we show how to can obtain directly the predicted distribution using OpenBooks. This is the parabolic regression example in which we have simulated data. It is not, the data is not real data, they are simulated data. It has been simulated from this example. We consider parabolic regression in which the dispersion of the standard deviation of the variances increases with the value of the regression variables as the square of these regression variables. And then we can build the commands of these examples, in which first we define the model, that is, we find that the dispersion tau is 1 divided by xi squared sigma squared. That is, we define the dispersion because you need to know that the OpenBooks software uses dispersions instead of variances or standard deviation. So we need the relation between the dispersion and the standard deviations. The second part of these commands include the data. We define the y as the normal random variables with the mu given later and the tau that has been defined above. Then the mu is a parabolic regression because we use xi squared. And then we just need to define the priors, which are for A and B and sigma are gamma random variables non-informative because we use very small values, 0.001 for this gamma. This is the Doodle model, and you can see that it is very simple and just reproduces the commands before. We can use this graphical display or the commands, any of the two is valid for compiling the model. And then we run the OpenBooks. And this is the final result. You can see the beautiful of having percentiles for the percentile curves and a very nice fit of the data in the model. In the commands model, we can include two different parts, one for the predictive prior and one for the posterior predictive. As before, the posterior predictive parameters must be linked to the sample and the prior predictive parameters should not be linked to the sample. This is well known to you because we have seen that before in other examples. And then the Doodle model is here and the corresponding commands window or the list of commands. It is interesting that using one of the menu options, the pretty print, we can move from the graph to the list of commands, so that OpenBooks generates the list of commands on the right from the plot on the left. And the plot of the left, you can see that has two branches, one for the predictive prior and another for the predictive posterior as before. And this is the prior predictive model on the right. Look that the percentiles now are very poor because we didn't include the sample data, and then it doesn't fit very well. However, in the posterior on the left, we have included the sample data, and then it has been corrected, and we have a very nice fit. And in this plot, we have the prior predictive and the posterior. You can see the very big difference between one and the other. In the other, we have only the information from the expert that is not very good, and in the other, on the right, you have the sample that dominates and makes the contribution of the expert negligible. And finally, we get estimates of the parameters as density functions. The priors are uninformative, but you can see they are uniform, and the posteriors are the result of our studies. And this is the end of this lesson dedicated to parabolic regression. This is an interesting example of heteroscedasticity, which suggests other similar uses of OpenBus for other problems. If you want to know new and interesting application of OpenBugs, you should apply models similar to the one in this lesson. We strongly recommend the reader to see the MATLAB codes to call OpenBugs from these and other examples, which are included as complementary course materials.